Hello and welcome to a video on proving triangles congruent. This is about proofs, and it's different from other kinds of problems. Okay, usually what you're doing is you're looking for an answer. In a proof, you're actually given the answer and you're trying to explain why it's true. So proofs are all about the explanation, and they're really much less about the answer, since the answer is going to be always given to you in the question, which is pretty much like, why is this true? That's what the question means in a proof. It's asking, why is it true? It's going to, in every proof, so just a couple things here. It's not about the answer. The answer is already given. The goal is to explain it. There's three different formats for a proof. We're going to look at two of them right now. One of them is a paragraph. Another one is a two-column proof. And they all say the same thing. And the third one is a flowchart proof, which we will look at, but not today. All right, these are really just different ways of saying the same thing. It's just a matter of how you lay it out on paper. It's kind of like a bulleted list compared to a paragraph, something like that, where you can really say the same thing, just sometimes a bulleted list is a little bit more less wordy and it's shorter, basically. All right, so let's look at our first proof. All right, so we're given some information and we want to prove something. Now, the most important thing to understand is that you have to always connect your explanation, whether it's a paragraph or two columns like we're looking at here. You always have to connect your explanation to a diagram. You can never just say something about triangles that nobody's even looking at. You got to see them. So that means it's really important that the diagrams have the marks on them to indicate your argument. You're referring to them, you're looking at them with your argument. And your argument is not a fighting kind of argument, it's an argument that's more of an explanation of why something's true. Okay, so you're given information and you're going to use the given information to prove something. Now, you're going to use statements and reasons in your proof. So your statements would be saying something like, we know, looking at this diagram, we know that these two angles are congruent. So it would be a fair statement to say in the proof, and I'm actually going to put this as statement number 4, and I'll tell you why in a minute. I'm going to put this as a statement that angle, now I can't just say angle L is congruent to angle L. I have to be a little bit careful about it and say that angle KLM is congruent to angle PLN. Right? And that's the statement. Now, why did I say that? Why do I know that that's true? It's not just like any two angles are congruent. There's a reason that these two particular angles are congruent. And that's because they're vertical angles. You can say the vertical angle theorem, but I'm happy with just saying it's because they are, and that's what reasons are. You don't have to write because they are. You just write reason, vertical angles. Okay? Now, other statements come from given information. Anytime you're given something in a proof, you're gonna use the fact that it's given as your reason, and you're gonna state it in the proof. So I'm gonna do that right now. I'm gonna state this given information in the proof. So it says L is the midpoint of KN, segment KN, and segment MP. Now, that's honestly the most annoying part of proofs, is that you see something and you have to copy the same exact thing. I don't like it, most people don't like it, but it's still got to be there. It's got to be a complete explanation in the part of the proof that's explaining it, which is the two columns. Now, why am I able to say this? Because it's given. And usually there's something given in a proof, but that's my reason. Now, one of the things that's confusing in all proofs, until you just kind of get the hang of it, is that the given, these are always going to be, this word will always appear in your proof if something is given. The prove will not. You're never going to use the word prove as your reason, because that's really what you're trying to get at. So you're not going to do that. All right, so what else do we know here? We need 3 congruences in order to say that two triangles are congruent. And our goal here is to prove that two triangles are congruent. That's our goal. And we know that there's a bunch of these shortcuts that we can use. So we don't know which shortcut until we mark up a triangle. Now, what we know is that if L is the midpoint of segment KN, that L is right in the middle, and therefore these two segments, KL and LN, are congruent. So I'm going to mark it on the diagram, and I can now say that. That's a statement. So segment KL is congruent to segment LN. Why? Well, it's not given. It doesn't say this up here, right? It's not given. So I can't use that for my reason. So what can I use? Well, it's the meaning of midpoint. And what we usually say, it's the definition of midpoint, which is it follows. Now this step has to come after step 1 because I can't talk about the midpoint. I can't say something that follows logically because of a midpoint unless I've mentioned first that there's a midpoint there. So the reason for this is the definition of midpoint. Okay. What else do we know? We also know that it's not only is L the midpoint of Kn, but it's also the midpoint of MP. So why don't we mark what's true because of that? Since L is the midpoint of MP, it follows that these two segments right here are congruent. So I'm going to write that, and it's the same reason. It's because it's the midpoint. So I'm going to write now that ML, segment ML, is congruent to segment LP. Why? Because that's the definition of midpoint. We can abbreviate this. We don't have to write it all out. So this is the definition, how about like that, of midpoint. All right, there's one more step, and that is the last step is always going to be, the statement will always be what you want to prove. So do I have enough information to draw this conclusion? I think I do. Looking at the diagram, I'm seeing that two triangles are congruent by SAS. Am I seeing that these two triangles are congruent? They're pretty much the only triangles there, but let's just make sure. M corresponds with P. Let's see, M and P, that makes sense because they're the ones right next to the two tick marks. K corresponds with N, so this angle over here corresponds with this angle over here. That makes sense also. And L corresponds with L. Those were already marked congruent. So yes, everything looks good. Honestly, you don't have to always check that much detail. We know that we've got an SAS situation. So we're able to say, now we're able to reach our conclusion that triangle MKL, triangle MK, you want to write exactly what you see, is congruent to triangle PNL. And again, this is never going to be because of proof. So these two things right here and here, they're different. In both cases, you write down what's given and you write down what you're trying to prove, but your reason for the given is because it's given. Your reason for the proof is whatever it is that follows on this triangle, which is, in this case, side angle side. That's your reason. All right, there's a 2-column proof. It doesn't mean anything if the marks on the diagram are not there. You have to have marked your diagram. If it's not marked, then I don't know where you're getting information or how you're really following your logic there. All right, so take a look at this. Now let's kind of move over here. And this is the same exact information in a paragraph form. So this is a paragraph proof of the exact same thing. A little bit smaller here if I want to show both at the same time. But I just wrote this out as the exact same information. And some people prefer paragraphs because it follows more logically. Since it's given that L is the midpoint of MP, there I just said this first line, right? I said it's given that L is the midpoint of MP. We know that MP is congruent to LP. And I didn't mention the word definition, but I'm saying it follows from the definition. So I've said the ML and LP, so I've said this one. Since it's also given that L is the midpoint of KN, that's also part of this first statement, we know that KL is congruent to LN right here. So that one is said. Here, since angle KLM and angle PLN are vertical angles, it's exactly what we have written right here in the statement. Since we know that they're vertical angles, we've said that. They must be congruent. And then finally we say all of this leads to the conclusion that triangle KLM is congruent to triangle NLP because of the SAS congruent shortcut. So it's wordier, but it's also more clear. So like I said, some people do prefer those paragraph proofs. In general, I'm going to do the faster. I'm going to use the faster method, which is the 2 columns. Just less words, and once you get the hang of it, it's kind of saying this, it is saying exactly the same thing. Okay, so let's take a look at another example. And here we're trying to prove that the 2 triangles that we're seeing in the picture are congruent. And I'm just going to tell you that one of the things, I don't always like this format, and you may not like it either, and that is being told how many steps there are. You might write this out a slightly different way, and this time I'm going to break this up a little bit differently, and that is that this time the 2 pieces of given information, they're not really connected to each other. They're really 2 different things. In the proof that we just looked at, the 2 pieces of information are both about a midpoint, and they're both kind of the same thing, so they can be put into one sentence. And by the way, you could have also put this into 2 different statements. You could say L is the midpoint of Kn as one statement if this was 6 spaces here, and that would be perfectly okay. And that's one of the reasons I don't like being limited and told how many spaces to use. I actually would have probably made this proof with 6 steps. But it's also easier if you see those number of steps in front of you to kind of know about how long the proof is. So it's good and bad. All right, so let's take a look at this one. This time, because these 2 pieces of given information are definitely very different, I'm going to do them separately. So I'm going to start out with the given piece of information, BD bisects angle ABC. Now, hopefully we know that that means that if we're looking at the angle ABC and we're looking at line BD, it's cutting it into 2 equal pieces. So we know from this that this angle here is congruent to this angle here. All right? That's the first part. So what follows from this, by the way, this is true because it was given. Put that back in black. So what follows from that is more important than the statement itself, and that is that angle ABD is congruent to angle CBD. And so that's not given, that's the definition of bisect, the definition of angle bisector. Okay, what's next? Well, we've used up that piece of given information, and from it we got 1 of 3 congruences. There's always going to be 3 congruences, by the way, because that's the nature of the shortcuts. I guess unless there's an HL proof, then you would only use 2 congruences. But there's 1 congruence, and that's, saying something, 2 things are congruent to each other. All right, let's look at the next one. Well, we're given a congruence right there. That's pretty simple. So we know, let's mark that. We know that angle BAD, that's here, is angle BAD, is congruent to angle BCD. Let's give that 2 marks. BCD here. That's pretty easy. It went right to the congruence. So we already got that piece of information. Now that's 2 down. And let's write that down. So angle BAD is congruent to angle BCD because it's given. Now we've got 2 things marked. Now every time I'm looking over here, I'm looking over here. And I'm doing what I've always done, what we've always done, which is to try to decide which shortcut we're using. That's what these are all about. So let's keep on going. We need more information. We've used up all our given information. And so hopefully you're thinking these 2 sides are the same. BD is congruent to BD. So we can say that here. BD, segment BD, is congruent to segment BD. I know it seems silly, but if we don't mention that there's congruent segments, we won't be able to use angle side, which is we're going to get to in a minute. Why are these congruent? Well, it's simple, because they're the same side. A little bit more formal, you could say it's the reflexive property. Most people just say it's the same side, and I'm fine with that. Okay, now we're looking at our triangle. We can see that these 2 triangles are congruent by angle side, and now we just need to say it. So our conclusion here, triangle ABD is congruent to triangle CBD by angle side. Okay, that's an introduction to proofs. I hope you find this helpful. Don't forget, always mark the diagrams and always use the given information. And your last step will always be what you're trying to prove, and your last reason if you're proving triangles congruent, will always be a triangle congruent shortcut.